Hello students, let us see a new concept that is called as types of constrained motions. In types of constrained motions, we have three types. The first one is completely constrained motion. Second, incompletely constrained motion. And the last one, successfully constrained motion. So we have three kinds of constrained motions: completely constrained motion, incompletely constrained motion, and successfully constrained motion. Now we will start with the first one, that is completely constrained motion. I'll say that the description of above are as follows. Now, first I'll describe completely constrained motion. In case of completely constrained motion, first I'll draw the diagram so that we can understand this. Now, completely constrained motion, it can be explained in such a way, like if we have a square hole in one of the disc, that is this vertical disc, if it is having a square hole, then we have a square bar. Now, whatever is the direction of force applied, this square bar will only reciprocate inside this square disc, we can say. Here we are saying that this is a square disc, and here we have a square bar. Now, in whichever direction we apply the force to the square bar, it will only reciprocate inside this square disc. So we can say that here the motion is completely constrained, because only translation is there. Because if we try to rotate this square bar will not rotate inside a square disc. It will only reciprocate. So we can say that whatever is the direction of applied force, the square bar will only reciprocate inside the square disc, and so the motion is completely constrained motion. This we have understood with a diagram. Now, incompletely constrained motion. In incompletely constrained motion, here motion is possible in more than one directions, that I can explain it with a diagram. Now, incompletely constrained motion, it can be explained with this diagram, where in a square disc or a rectangular disc, in a square or rectangular disc, if we are having a circular hole and in that we are having a circular rod, then we can see that this rod, it can reciprocate inside the disc as well as it can rotate inside the disc. So here the motion becomes incompletely constrained, because if it was just rotating and not translating, then it would have been completely constrained motion. But since here it is rotating as well as it is translating, it is called as incompletely constrained motion. Next, successfully constrained motion. In case of successfully constrained motion, if we have incompletely constrained motion and when we are making it into the form of completely constrained motion, that step is called as successfully constrained motion. I'll explain it with a diagram.
Suppose we have a shaft
which is rotating about an axis and shaft is mounted in a bearing. So this becomes a footstep bearing where we have a shaft which is rotating and it is rotating inside a bearing. Now as we see here, when the shaft is rotating, there is possibility that the shaft can even move up. So it is an example of incompletely constrained motion. Now if I want to make it successfully constrained motion, then we would be placing a load here, a load, or you can say weight. Because of this weight, the shaft cannot move up. Hence we have completed, or we have converted incompletely constrained motion into a, you can say, completely constrained motion, that is shaft can only rotate, it cannot move up. So this is an example of successfully constrained motion.